Welcome everyone. So in this video we're going to learn limits. So let's go ahead and compute some limits. So our first example is this problem right here. We want to find the limit as t approaches 4 for the function 3t minus 7. Now if you notice, now this is a nice linear function. It's a polynomial, so we know that this function is continuous everywhere. Therefore I can just simply substitute 4 into that function, and that will be the limit. So let's go ahead and do that. So we have 3 times 4 minus 7. So that will be our limit value of this function, which will simplify to 12 minus 7, and that would give us 5. So the limit of this function is 5 as t approaches 4. Let's go ahead and try another example. So for this example, we are taking the limit as x approaches 2 of this given function. Now this is a rational function because you have a polynomial over another polynomial. So if you try to do direct substitution, take a look at what happens. So if I plug in 2, I get 2 squared plus 2 minus 6 over 2 minus 2, which is equal to 0 over 0. So if you get something like this, we can't really direct substitute. We have to use some preliminary algebra to simplify this, and then we can try direct substituting. So let's go ahead and do that. So let's consider this as our side note. If you get 0 over 0, then this is what we want to do. We want to simplify this function as much as we can. So the limit as x approaches 2 of this function. Now I can try to factor the top. Looks like it's factorable. We get x plus 3 and x minus 2. And on the bottom, it's simply x minus 2. Let's put parentheses around. Now here I can cancel out common factor from top and bottom, which happens to be x minus 2. Then this simply comes down to the function x plus 1. So we have the limit as x approaches 2 of this function x plus 3. And now I can do the direct substitution. So plug in 2. You have 2 plus 3, that gives us 5. So the limit of this function is 5. Alright, here is another problem. So go ahead and pause the video, see if you can work it out on your own, and then check your answers with me. So again, if you try to substitute 4 into this rational function, we will get 0 over 0. So try that on your own, and you'll see that by substituting 4, we get 4 squared, that's 16, minus 4 times 4, 16 over 4 squared, 16, minus 3 times 4, that's 12, minus 4. So again, we get 0 over 0. Now in this case, again, we want to try to use some preliminary algebra to simplify the function and then use direct substitution again. So let's go ahead and do that. Simplify this function. We have the limit as x approaches 4 of, now top I can factor it into x times x minus 4, and on the bottom I can factor that into let's do x minus 4 and x plus 1, and that would give us that quadratic. And now it looks like I can cancel these factors, so I'm left with the given expression. Now I have the limit as x approaches 4 of x over x plus 1. And now I try direct substitution again. So that gives me 4 over 4 plus 1, which would give us 4 over 5. So that will be the limit of this problem. So again, you see how if you get a statement like 0 over 0 for these limit problems, try to simplify it by factoring, and or sometimes you might be able to simplify by using conjugate. So that's what we're going to talk about next. Now for this problem, again, if you try to do the direct substitution, you see that on top you get 0 and on the bottom you get 0. So again, we get this indeterminate form. So that means we need to use some preliminary algebra to simplify this, and then we can try direct substitution again. So the way we're going to do this is going to be by done using the idea of conjugate. So if you recall that if you have a term, let's say a plus b, then the conjugate of this expression, it's going to be a minus b, so that when you do a plus b times a minus b, you get a squared minus b squared. So that's the idea we want to use here. So I want to multiply this limit, top and bottom, by its conjugate. So we have the limit as h approaches 0 of the square root of 1 plus h minus 1 over h. So we're going to multiply top and bottom by its conjugate. So that would be the square root of 1 plus h minus plus 1, because this is the conjugate, times the square root of 1 plus h plus 1. And let's put parentheses around. So once I do that, I can continue on with simplifying this. So the limit as h approaches 0. Now on top, of course, when you multiply by the conjugate, you get this difference of two perfect squares. So think of as this is sort of like your a term, and this is your b term. So if I multiply a plus b with a minus b, I get a square b square. So this would come out to be the square root of 1 plus h squared minus 1 squared. So like I said earlier, think of as this is your a and this is your b. Okay, so once we have done that, we expanded the top, we got the difference of two perfect squares, and the bottom is just simply h times the conjugate, 1 plus h plus 1. And then by further simplification, we have the limit as h approaches 0 of 1 plus h, because the square root will cancel with the square, and then minus 1 all over h times the square root of 1 plus h plus 1. And this will simplify to the limit as h approaches 0. We know that these will cancel out. So on top, we're left with h, and on the bottom, we have h times the square root of 1 plus h plus 1. And here again, you should notice that the h's canceling each other out, and that gives us the limit as h approaches 0 of 1 over the square root of 1 plus h plus 1. And now we can try the direct substitution again. So that would give us 1 over the square root of 1 plus 0 plus 1. And now we're ready to evaluate this. This is 1 over square root of 1, which is 1 plus 1, that's 2. So the limit of this function is 2. All right, so I hope this makes sense. So that's it for here. I will see you guys next time.